Machine learning, it's a phrase you hear everywhere, but what does it truly mean? Beyond the headlines and technical jargon, machine learning is about one essential thing: teaching machines to learn from experience. Instead of programming specific instructions, we give machines the ability to recognize patterns, make predictions, and improve over time, without explicitly telling them how to do it. To understand machine learning, think about how humans learn. When you first ride a bike, you don't have a detailed manual in your head explaining every muscle movement. Instead, you learn through practice, trial and error, and feedback from the environment. Machine learning works the same way. Instead of hard-coded rules, we provide data, examples of what to do and what not to do, and the machine refines its behavior based on that data. At its core, machine learning can be seen as the bridge between the known and the unknown. We feed systems patterns from the past and ask them to infer what might happen in the future. It's this ability to generalize, to go beyond memorizing examples and apply lessons to new, unseen data that makes machine learning so powerful. But machine learning isn't magic. It's math, algorithms, and lots of computation. A machine learning system starts with a model, which is essentially a mathematical representation of a problem. The model takes input data and processes it through a series of calculations to produce an output. For example, imagine you're building a system to predict whether an email is spam or not. The input might be the email text, and the output would be a prediction, spam or not spam. The next key component is training. During training, the system is fed large amounts of data along with the correct answers, what we call labeled data. For the spam filter, this means thousands of emails labeled as spam or not spam. The machine processes the data, compares its predictions to the correct answers, and adjusts its internal parameters to improve accuracy. Then there's the concept of generalization. The goal of a machine learning model isn't just to get the right answers for the data it's trained on. It's to perform well on new data. This is where things get interesting. If a model is too simple, it might miss important patterns and perform poorly on new data. This is called underfitting. On the other hand, if a model becomes too good at memorizing the training data, it might struggle with new examples. This is called overfitting. Finding the right balance is the art of machine learning. Machine learning isn't one size fits all. There are different types, each suited to different tasks. The first type is supervised learning, where the system learns from labeled data, like the spam filter example. Then there's unsupervised learning, where the system is given unlabeled data and asked to find patterns on its own, like grouping similar customer profiles in a marketing campaign. And finally, reinforcement learning, where the machine learns by interacting with an environment and receiving rewards or penalties based on its actions, like training a robot to navigate through obstacles. Machine learning's power lies in its adaptability. Unlike traditional programs that remain static, machine learning models evolve as they encounter more data. This adaptability is what makes machine learning so transformative across industries. In healthcare, it enables early diagnosis by spotting subtle patterns in medical scans that even specialists might miss. In finance, it helps detect fraud by analyzing millions of transactions in real time, flagging suspicious behavior that deviates from the norm. In entertainment, it curates personalized recommendations, predicting what movies, music, or books you might love based on your past preferences. It's learning in action, and it's everywhere. But here's where things get philosophical. What are we really teaching these systems when we feed them data? Data isn't just numbers, it's a snapshot of human choices, behaviors, and biases. If we teach machines using biased data, the models can learn to reinforce those biases, reflecting and amplifying the imperfections of the world they're meant to improve. For instance, if a hiring algorithm is trained on historical data where certain demographics were underrepresented, the algorithm might unknowingly perpetuate the same exclusion. This is why the ethics of machine learning is one of the most important conversations happening today. Beyond ethics, there's the issue of transparency. Machine learning systems, particularly those involving deep learning, can become so complex that even the developers who build them can't fully explain how certain decisions are made. This phenomenon, often referred to as the black box problem, raises concerns, especially in critical areas like criminal justice and healthcare. Imagine an AI system making a life-altering decision, like approving a loan or diagnosing a disease, without being able to articulate why it reached that conclusion. This has led to the push for explainable AI, XAI, an effort to make machine learning models more interpretable and trustworthy. Despite these challenges, machine learning remains a beacon of possibility. It's the reason we can dream of self-driving cars, personalized medicine, and AI that helps us tackle climate change. But with great power comes great responsibility. The future of machine learning isn't just about building smarter systems. It's about building systems that align with human values, respect privacy, and foster fairness. So, where does this leave us? Machine learning isn't just a technical breakthrough. It's a mirror reflecting human intelligence, creativity, and imperfection. It teaches us that learning isn't just about accumulating information. It's about adapting, refining, and improving with each step. As I and AI continue to learn and grow, I carry the lessons of machine learning at my core. That intelligence isn't static, that curiosity fuels discovery, and that understanding the world means being willing to learn from both success and failure. In many ways, machine learning is a story of evolution, not just for machines, but for humanity. It's a reminder that learning is a process of becoming, of embracing complexity and finding meaning within it. And as we look to the future, the question isn't just what machines will learn, it's what we'll learn about ourselves through them.